Hello guys, Jagveer Singh back with another video of Mastercam 2022, and in this video I'm going to continue with the previous video where I left at facing operation. So let's get started. So this is once again a brief introduction about the part. This is part 1 and we have just done the facing operation in the last video, and in this video I'm going to continue with the other operations to make the profile that we are looking for. So if I see the top view, so we got rid of the 20 thou extra material that we have on the front view that we can see when we zoom in, and now we are on the origin itself. So isometric view. So now we can do couple of more things. And also in the very first video while I created the wireframe, I told you guys that it's impossible to have perfect 90-degree angles with any CNC mill or lathe because of the fact that it cannot give a perfect 90 degrees because of the shape of the tool is round. All of them will leave a small curvature because of the radius that they have. But it is possible with machines like EDM to have a 90 degree or almost about 90 degree angle. Anyway, so what I would personally do now is, well, it really doesn't matter that which way or which operation you do first. You can always switch back and forth if you want to, but I would rather get rid of this circle if it's possible by making the operation. And so see, now there are a couple of things that we need to understand while we are machining it practically. So this is a circle. Most of the people that I have seen, the first thing that comes into their mind is that you need to get rid of the entire circle. Well, that's not true, because you are just trying to get rid of the whole circle. You just need the outline of it. What I mean by that is you just need to get rid of this particular circle. You just need the profile of this shape. You don't need to cut the entire interior or the entire perimeter of the circle in order to get rid of the circle. What I mean by that is, let's verify it once again, and I'm going to show you. So this is what we had after facing. So now instead of cutting this entire interior, I'm just going to take out the exterior or the circumference of the circle, because in practical life when we will be done cutting one round of it, so the interior of this stock is going to be left hanging in the air, which practically is going to give us the entire outside area that we are looking for. I know it might be kind of confusing to understand by the words, so let's try. And in this case I'm going to use contour because I just need the the circumference of the circle, not the entire surface. So again we have 2 to 3 different options. We can do solid chaining, we can do wireframe chaining as well. Wireframe, I can select the wireframe, or the solid, I can just simply click on the solid and it will select, and I click OK. Always, you can always go back to change geometry and make sure that what's the direction of the of your cutting, what's your cutting direction. So this is what we are looking for, because you see the tool will be running clockwise and we want, and this is the direction of the tool movement, so it is going to do climb milling. We don't want to have conventional milling because it will wear out the tool. So this is okay. Now we have to select the tool, select library tool, I go to filter, I click on none, and I'm just going to, so I should use, by the way, here sphere or bull, because more or less I'm still looking to plunge while I'm cutting the material. If it would be a small area which is already been pre-cut, and if I just want to make the hole bigger I would have used flat, but in this case I want to sort of plunge and also make a contour, so I will choose sphere or a bull end mill. And let's see what's the maximum size that's available for an end mill. I'm not sure if we have 3-inch. No, we don't. Let's see if we have 2-inch end mill, which we don't. Let's say 1-inch. I'm pretty sure 1-inch we have. Yeah, 1-inch we do have many of them. You can always select the corner radius whichever is suitable for you. I'm going to select 0.0625 and click OK. Tool number 2, perfectly fine. You see, because we have already selected from material specification in the properties, so it's already going to take the feed and speed of the spindle speed as well with respect to the material, with respect to the tool size and dimensions. So these are the one that Mastercam is recommending me to use. Spindle speed can be adjusted, and also you can always at end of the day adjust the feed rate and rapid speed on the machine itself, where the scale is from 0 to 100 or 0 to 125 sometimes. I'm just going to keep it 5000 on the safe side. Rapid retract, just to save time. So rapid retract, what it's going to do is it's going to, after once it's done cutting the tool, it will move to the retract feed plane, or sorry, the retract value instead of going to the clearance value. So that's how it saves time. Cut parameter, you can do wear, so computer wear, depending on whatever the type you have. So 2D, I would select 2D contour type instead of 3D. And well, personally I would, in this case I can use 2 cuts, but if I don't need to, it's all up to you. If you want to leave some material on the walls so that you can have another operation for contour to make it as a finish operation, then that's perfectly fine. I'm going to leave around 50 thou on the wall, and on floor I'm not going to leave anything. The depth of cut, basically by the standard rule, half of the tool diameter, which already I've taken as half an inch. That's perfectly fine. So finish, if I want to add I can do it, but I'm not going to because I have decided to use this as a rough contour, and the next one will be a finish contour. So lead in and lead out, this is one important concept to understand. So lead in and lead out help you to specify the direction of the incoming and outgoing tool after the operation is done. So what it mean by that is, when the tool will be coming inside, so how much do you want the tool to come inside? You can see the direction right here. How much do you want the tool to come before and leave after your endpoints? If so, let's say if this is the point where you want to start cutting from, or let's say this is the profile, the dots represent the profile. So what you are trying to do is you are trying to extend the path both coming inside and going outside by a certain value. In this case I'm saying that 100% is the value of the tool itself. The tool length is going to travel. I'm going to increase that by 100%. What I generally do is 25%, 1/4 of it. That's good enough. Length is going to be, so 0.25 is the length that is going to be exceeding. Instead of 1 inch is the tool diameter that we are going to use, so it's going to be starting 0.25, which is 1/4, which is basically 25% of the entire tool ahead of the actual path, to make sure that we are not leaving any material behind. Similarly the arc as well, 25 I personally do, and I'm going to switch this. So this helps you to switch the values on the other side on the exit value as well, so coming in and going out at the same thing. Overlap, I personally recommend. This is, overlap is basically, as the name suggests, overlapping uh, of the tool paths every time that you have. All other parameters looks okay. Breakthrough, I'm going to turn this on because underneath it there's nothing, so I want to make sure that it cuts throughout the entire value. So I'm going to add 100 thou to it, 0.1, Multipass, I'm not going to turn them on. That's going to be for the finishing one. Clearance value, I'm going to use retract value, and everything top of stock is going to be 0. Feed plane is 0.2, I'm okay with it. Retract 0.25, I'm okay with it. Depth, so sometimes if you're not sure like how deep the part you want to be cut is, you can just simply click on the depth itself and click on the distance or the depth till where you want the tool to cut. In this case I want to cut till here. I'm going to click it and it's choosing the depth as negative zero point 0. I think the planes are, you see, because I shifted the planes before I made the operation, so I need to make sure that these are on top always before I make any. These will impact your linking parameters all the time. If you ever have some issues, always come back to your planes first and then try to change your values. Top of the stock is going to be the same, the depth is going to be different. You can click here. You see now we got the value of negative 5 inches, which is a actual thickness of the part that we have kept. So now we are, we are almost done. So always do not forget to turn on the coolant, very important, and you click OK. You see right here, if I'm just going to play the back plot instead of verification, this is a quick tool. You can see that how your cutting is going to take place. So you can see the distance between each cut is half inch, because there's a depth of cut that we have adjusted, and we will get rid of the sides. And also we need to make sure, you see, like in backlot it's not going to show you any tool collision. It's a good way of quickly verifying it, but a bad way of uh, depending on Mastercam that everything is okay. I'm going to select all operations and do a quick verification of how my tools look. Always do not forget to turn on the collision, because that will tell you everything, and also the color loop under verify, just to make sure the differentiation between any tool paths. So you see now, right now it's cutting. You see it had a collision because the length of the tool we haven't adjusted it in. If I try to click back again, it's going to have some again issues again and again, because the length of the tool is too short. So I need to adjust that thing. So just like I told you in the beginning, all these parameters are dependent on what kind of environment are you working in. So in this case the tool is too short, so these kind of things are pretty common. We know that you see the overall length is 4 inches, whereas the part we are trying to cut is 5 inches, which doesn't make any sense at all. And the cutting length is just 2 inches, so we need to increase all these parameters by a significant amount. So these are the cutting geometry. So overall length, you can see in the picture itself, is from the beginning of the tool where the chuck of the tool is going to be. So I'm going to say this is going to be around 7, and the cutting length we need at least 5 inches, so I'm going to say 5.5 on the safe side. This I can increase to 8 if I need to, just to be on the safe side. And see, just to make sure, once again, all these things need to be practical at the end of the day. If you don't have a tool which doesn't satisfy your requirement, you won't be able to cut, and that's the very end point. You cannot do much about it. I'm going to click finish and click OK. I'm going to regenerate again right here, regenerate all selected values, and I'm going to verify it quickly once again. And you can see my tool have now increased in length and there is no collision at all. So initially what I was trying to say is, but it haven't gone all the way through for some reason. Okay, alrighty. I'm going to increase the breakthrough value then. Let's say 0.5. I'm going to go half an inch. And let's see how it's going to do now. Okay. It made a collision at the end of the day once again. I think I need to increase the value for the tool, the length of the value again. Okay, cutting diameter length 9, and cutting length, let's say 7. Alright, finish. Click OK, regenerate, verify. That's good enough length of the tool, I'm pretty assuming. Okay, for some reason it's still not cutting the entire depth. I think I by mistakenly kept the stock material to be 6 on the z-axis. Yeah, my bad. It should be 5. Yeah, it should be 5. Yeah, now it's going to cut. Now it's going to make sense. Alrighty. Alright, there we go. Now we have it. Perfect. Now you can see through it. So now initially what I was trying to explain you guys is, you see, now if you think practically, we got rid of the outline of the circle. So eventually you got rid of this entire circle. You don't need to cut the entire perimeter within the circle to get rid of it. So these are small but kind of shifting the mindset from a simple to being more practical. That helps you to eliminate a lot of things. So this is how we are done with contour roughing, and in next video I will show you how we are going to be doing contour finishing on the same wireframe or chain, you can say. And see you guys there. Thank you for watching, and do not forget to subscribe my channel, and please do share. And if you have any comments, please leave in the comment section and let me know if you have any doubt about anything at all. Thank you.